As we talked about in 5.2, the main difference between solving multi-step inequalities and solving multi-step equations is that when you multiply or divide an inequality by a negative, you must switch the inequality sign. All right, if you have -2, that is obviously less than 3. But if I multiply both sides by negative, or divide by -1, if I just multiply by -1, that changes the value to +2 and -3. And if I keep my inequality sign, that is a false statement. So I must switch the inequality sign in order to keep the statement true. So that's why we'll always say if you multiply by a negative, you switch the inequality sign. So 2 is greater than -3. That is what will make that statement true. All right, the others are just to review, and we can do those on our own. We're now moving into section 3, where our objective is to be able to solve multi-step inequalities. We're going to have to do more than one step, and we do this by reversing the order of operations. We're undoing what has happened to y. So instead of PEMDAS, I guess we would say sad meat would be the reverse order of operations. Ha ha ha. Bad joke. All right, what's happening to y? It's being multiplied and added. So instead of multiplying first like we would if we knew what y was, we are going to undo adding by subtracting 3. So -8y is greater than -8. I need to divide by -8. Woo, woo, woo. I hear sirens going off. We are dividing by negative. Warning, warning. We must flip or switch our inequality sign. So instead of saying y is greater than, I'm going to say y is less than, and -8 divided by -8 is +1. So we come to the number line and we can label it just a few. You don't need to fill in all of the numbers on the number line. So our graph is going to be an open circle on 1 because it's not equal to, and with the inequality sign flipped, it's going to be less than. So anything less than and not equal to 1 is the solution that will make this inequality true. Now you can always check yourself, and in order to check these, you need to pick a number less than 1. So I'm going to come over here and check. Let's pick 0. That's less than 1. -8 times 0 plus 3. Is that greater than -5? Putting it into the original equation. So 0 plus 3 is greater than -5. I agree. 3 is greater than 5. It checks out. So beware. On number 2, we have a +13. This negative really belongs to the 11. So subtract 13 because it's positive, and -11d is greater than or equal to 66. Divide by divide by -11 because it's a negative. I need to be aware. I must switch my inequality sign, and d is going to be less than or equal to -6 because I switched my inequality sign here. And so to come graph that, -6 to the right is -5, -4, to the left will be -7, -8. Is it an open dot or closed dot? This one's a closed dot because it's less than or equal to, and less than goes to the left. So that's how you would graph that inequality. For number 3, let's start with subtracting 7. So -t/5 is greater than -11. And now, how do we undo what's happening to t? We'll need to multiply both sides. Let's multiply by a -5 in order to make our t positive. When we multiply by -5, this cancels and the t becomes positive. And we have sirens going off again because I multiplied by a negative. So flip your inequality sign, and -5 times -11 is a +55. So you find 55, 56, 54, 53, and open circle because it's not equal to 55 and it's less than. Now it's a coincidence that all of these are turning out to be less than. That's just poor planning when I made out the notes. First thing I'm going to do to number 4 is to undo what's happening here by multiplying by 5. I've told you before, if you don't like fractions, you can make them go away. So now we have 5h less than or equal to, it was not a negative, so I don't have to flip any signs. Subtract, well now, hang on, I started to say subtract 3, but I'm going to change my mind. Let's get all of our h's on one side, so let's subtract 6h. And that leaves a negative h less than or equal to a positive 3. I don't want negative h, I want positive h. So what do? I multiply by negative 1, and positive h is greater than or equal to a negative 3, because I'm multiplying by negative 1 to get my h positive. I didn't write that down, so let me try to get that going. Negative 1, multiplying. Now, at negative 3, negative 4, negative 2, it's a closed dot because it is equal to, and this time h is greater than, so the arrow's going to the right. Now, a little hint, if you write your variable first, your inequality sign is pointing the direction of your arrow. So that's a way to kind of check yourself. And again, pick a number greater than negative 3. How about 0? 0 is greater than negative 3. When I come over here to check, 0 less than or equal to 6 times 0 plus 3 over 5. That's 0 less than or equal to 3/5. Is 3/5 greater than 0? You betcha. And so it does check out. Alright, define a variable and write an inequality and solve the problem below. 4 times a number. So it's a number. I don't know the number, so let's pick a variable. How about n? N can stand for a number. 4 times a number plus 12 is less than, so it's less than, not equal to, is less than a number minus 3. It should have said the number because they want us to just have one variable here. So it's less than that same number minus 3. And then you have variables on both sides. So I would subtract n, and that'll cancel. 3n plus 12 is less than negative 3. Subtract 12, and 3n is less than, and by the way, it's going to be a negative 15. Divide by 3. My answer is negative, but I did not divide by negative. So I do not need to have any sirens go off. I end up with a negative answer, but I got there dividing by a positive number. So whatever n is, it needs to be a number less than negative 5. I'm going to let you practice B and C, and we can talk about those tomorrow in class. Let's go down to a real-world example. Both of these real-world examples have provided you the inequality, but let's see if we can see how they came about, this inequality. Adriana has a budget of $115 for faxes. The fax service she uses charges $25 just to activate an account and then 8 cents per page to send faxes. So in other words, she has to have 25 and then it starts being charged per page. And her budget, which means that's the most she can spend, is $115. So she needs to either equal $115 or stay under $115. So when you get ready to solve this equation, I'm going to go ahead and rewrite it here in the middle. We're going to subtract 25 from both sides. And then we're going to have 0.08p less than or equal to 90. When I divide by 0.08, I end up finding out that she can send as many as 1,125 faxes. So she needs to send less than or equal to 1,125. I'll let you try number 2 on your own. And next we're going to have to work on our good friend, the distributive property. When solving inequalities that contain grouping symbols, such as parentheses, the distributive property is used to remove those symbols first. Then we go back to using reverse order of operations. So let's look at an example. The first thing we do is get rid of our parentheses, so I need to distribute 3. So 6c plus 3 times 2 is just 6, minus 3 times c, which is 3c, greater than or equal to negative 2c plus 1. I like to call this a little light housekeeping. Let's go ahead and get our c's together on this side. We have 6c minus 3c, so we have 3c plus this 6, which was not a like term. And now we need to bring all of our c's to one side, so let's add 2c. And that gives us 5c plus 6 greater than or equal to 1. So I need to subtract 6 from both sides. And 5c is greater than or equal to negative 5. Divide by 5, and c is greater than or equal to negative 1. And that's your final answer. I did not divide by negative, even though I have negative 1 as my outcome. I got it by dividing by positive 5. So it is equal to negative 1, or it is greater than negative 1. Again, my inequality points the same direction as my arrow. Since I ran over into number 2, I'll let you do number 2, and let's scroll down and do number 3. Distribute your 9. 9x plus 9 plus 11 less than. Distribute that negative 2. I say give poor negative 2 a hug, so you'll remember that the negative goes with the 2. So it's plus a negative 26. Combine like terms. 9 and 11 can be combined, and that makes 9x plus 20 less than negative 2x plus negative 26. Go ahead and we could subtract 20. That's supposed to be plus a negative. Okay, subtract 20. Cancels. 9x less than negative 2x minus 46. Add 2x to both sides. Again, I'm running out of room. And 9 and 11x less than, that cancels, and that was a negative 46. Divide by 11, and 11 does not go evenly, so I am going to go ahead though and write it x less than negative 4 2/11, and I need it mixed for the sake of graphing it. So I know if this is, let's get a different color so it'll show up. If this is negative 4, and that's negative 4.5, negative 4 2/11 is going to be about right here. And so it's less than, and it's not equal to, so whoops, that should have been an open circle. An open circle on, so see, this is negative 4.5, so somewhere between negative 4 and 4.5, and I still left it closed. It must be an open circle, and it points to the left. And I squiggly line it just because if this was a real pencil, it wouldn't show up. So you're welcome to squiggle your line so I can see it, and for sure put an arrow, and I'll know that you knew that it was less than. And I have a negative answer, but I got there by dividing by a positive 11. Notice I'm saying that out loud. That is me checking myself to see that I wasn't supposed to flip my inequality sign. I call these elephant problems because how do you eat an elephant? One bite at a time. So with a big long problem like this, we first distribute our negative 7. We then come over here, and please notice that this is distributing a negative 2. Give it a hug so you'll remember that the negative goes with the 2. Try this one without me, and I'm going to show you the results in just a minute. Pause the video. Please stop the video. So as I try to solve for s, you'll notice that the s's cancel, and I'm left with negative 48 is greater than or equal to negative 2. And this is a false statement, because remember, when two numbers are negative, the bigger the number, actually the smaller it is. So this is a false statement. If it's a false statement, the answer is empty set, no solution. Had it come out to be a true statement like this, had we come upon 24 equals 24 or something like 0 equals 0, which is a true statement, then the answer would have been all real numbers, and you could use your fancy R to stand